Welcome to this section on securing your microservice. Security could easily cover a whole course. In this section, however, I will only provide a brief overview of security in AWS to ensure that your serverless microservices are secure. Before we create our first microservice, we first need to understand the AWS security models. We're going to begin with the first video, which is an overview of the security in AWS, where we're going to discuss different terms that are important and the overall AWS security model. We are then going to talk about IAM, which is used to access any of the AWS resources. IAM stands for Identity and Access Management and is essential in terms of configuration that will be required, for example, in our Lambda functions to access any of the data services. Finally, we're going to talk about in details around securing your serverless microservice. We're going to focus specifically on what we're going to be building in the next section, which is the basic data provider microservice. So we're going to be focusing on the services of the Lambda, API Gateway, and DynamoDB. In this video, we are going to provide an overview of the security in AWS. In this video, we are going to take a look at why security is important, provide some examples of security, discuss the types of security terms that are important, and talk about the AWS shared responsibility model. So why is security important? Compliance with the law and standards, for example, the European Union General Data Protection Regulation, or GDPR, which will come into force in 2018. Health Insurance, Portability and Accountability Act, for example, HIPAA. Data integrity is also another aspect of why security is important. Systems that aren't secure could have the data stripped or even tampered with, which means that you can no longer trust these customer data or financial data where you get the reports from. Personal identifiable information is also important. Privacy is everywhere nowadays. The main idea is that you should really protect all your user data and assets as a matter of course. Data availability, in addition, if an auditor, for example, asks you for specific data, you need to be able to retrieve that data. If a natural disaster happens to your data center, again, that data needs to be available and secure. So on the left, we have various systems which are not configured correctly, or missing updates, or have insecure communication means. This could actually lead to, in the middle section, various problems where the systems will get hacked, or there'll be a ransomware demand, or there could be an infiltration into your systems. A distributed denial of service attack could be made, for example, which will bring down your e-commerce website, which will no longer be available to customers. And on the right, I've got some of the impacts. There could be litigation costs, for example, data loss or data leaks, financial costs to your organization, as well as reputational costs, of course, to your customers and clients. A lot of the security in AWS is actually configuration and just having the correct architecture in place. So it's important to understand some of these simple terms in security. Security in transit, you could think of this as HTTPS, SSL. If you think about a web browser, you would have the padlock in your browser to show that the communication is secure. For example, when you're accessing any of your online banking systems. Security at rest is basically the data that's encrypted in the database, for example, or a file system, and only a user with the key has actually access to the data in that database. Authentication, for example, is the process to confirm when a user or system who they are meant to be. Once you're authenticated, then a system usually checks for correct authorization. This is to check that the permissions and access controls are in place for accessing the specific AWS resources. This is a diagram of the AWS shared security responsibility model. It shows what AWS is responsible for and what you as an organization are responsible for. For example, you should not check in your AWS keys into a GitHub public repo. And yes, this has happened before in the past. So it's really your responsibility to ensure that the keys are secure, your data is encrypted. You can see on the top in blue, we have the customer data. So you're ultimately responsible for your data, for the platform application, and the identity and access management. Not as relevant for the serverless world, the operating system, network, and the firewall configuration. And you need to think about different encryption mechanisms. And you can see that AWS is responsible for everything in yellow at the bottom.